Let's calculate the values for a box plot for the lower limit, the upper limit, and all that, the median, the first quartile, the third quartile, the second, everything. Let's just come up with some numbers. So 5, 12, 18, 22, 27. They're the numbers we want to deal with. That's just a quick reminder. So a box plot is basically, we have the middle 50% of the data in this box, and that runs from Q1 to Q3. The median can be anywhere in this box. The median is the same as Q2. It can be anywhere in this box, and depending where it is, it tells us if the distribution is skewed to the right, skewed to the left, or symmetrical. And then we have an upper limit and a lower limit. And also we have this distance in here is called the interquartile range, and it's actually going to be Q3 minus Q1. So Q3 minus Q1 is known as the interquartile range. And this value in here is just Q2, or the median, so we can just put Q2 or the median. And then the upper limit is going to be Q3 plus 1.5 times the interquartile range. And the lower limit on the other side is going to be Q1, so we get this value in here, minus 1.5 times the interquartile range. And we also said that if we get any values falling out here or out here, they're deemed to be outliers. They're too far away to really be part of that distribution, and then not what we're expecting. What I've shown you there is just one school of thought. Other people will calculate the upper and lower limits in a different way. But this is one of several methods that we can use. So if you look up YouTube videos or read other books, you may find that they use different methods to the ones that we're using. So at any rate, let's stick to the methods that we've got here, that we've seen in the previous video. And what can we do? Well, the easiest way to actually do these calculations is to use Excel. And we can start off, let's just do it here. Q1 is quartile 1, is this value in here. And Excel can work it out for us, equals QUAR quartile. Now there's quartile excluding and quartile dot including. Again, there's two different ways of actually calculating the quartiles. One we're going to use is EXC, excluding. We're excluding the endpoints when we do the calculation. There's another school of thought that includes the endpoints, but we're going to use exclude the endpoints. And we're going to put our data into here. We put our data into here. In comma, we want the first quartile. Let's put comma 1. And we're going to get 8.5. The second quartile, quartile 2, or the median, is going to equal to QEAR quartile dot excluding. And this will be the second one, so we're going to put comma 2. And Q3, the third quartile, is going to be equals quartile dot excluding comma 3. If you want, we can do a quick check over here that quartile 2 is indeed the median. So let's do equals median. Equals median. So equals median of these numbers, and hopefully it's going to come out to 18. So the median and Q2 is the same thing. So we've got the Q1, we've got Q3, we've got Q2, and what do we need to do now? Well, we can work out the lower limit and the upper limit. And to do that, we're going to need the interquartile range. The interquartile range is just going to be equal to Q3 minus Q1. So the interquartile range, that distance in there is 16. So what else do we have? Lower limit, just call it LL for the lower limit. So the lower limit is going to be the value in here. That's going to be equal to Q1 minus 1.5 times the interquartile range. It's a negative number, it's okay. The upper limit is going to be equal to Q3 plus 1.5 times the interquartile range. So it's going to be equal to Q3, which is this guy, plus 1.5 times the interquartile range. And so pretty much all the numbers that we need to put in here. How about the skewness? Where does the median lie in this particular case? The median is 18. How far is it away from Q1? I mean, Q1 here is, let's see how far it is away from Q1. 18 minus 8.5. And let's see how far the median is away from the right-hand side, Q3. So Q3 minus Q2, 6.5. What does that mean? Where is that? Well, this point here is 8.5. Let's do the box plot again. I think it'd be clearer to do it over here. The box plot is here. So we just do the box part. So the Q1, so I've just brought this down to here. The Q1 is 8.5. The Q3 is 24.5. The median is 9.5 units away from this, 9.5 units away from this side, and it's 6.5 from this side. So it's going to be closer to this side, but it's only 6.5 units away from this side, and it's 9 units from that side. 9.5. I've exaggerated it so we can see. So this would suggest that we have a negative or left skew. And that's pretty much all you need to do. Excel does the work for you. Now, we could have actually worked these out. I'll show you how to work these out. You don't really need to know how to do this, but some students will be interested in how you would actually go about solving these. So we have Q1. How do we find Q1? How do we find Q2? And how do we find Q3? The rest of what I did down here for the interquartile range, once you know Q1, Q2, and Q3, it's just formulas. So let's just figure out how you find Q1, Q2, and Q3. Well, there's a little formula that we use to find the position of quartile 1. So this is going to be position 1, position 2, position 3, position 4, and position 5. So the way we find the position of a quartile is this. It's the sample size, which in this case is 5, plus 1 divided by 4. That's the position of quartile 1. So I put P1, that's the position of quartile 1. And how do we find the position of quartile 2? Quartile 2, remember, is the median, but we're just looking for the position, not the actual number. That's going to be n plus 1 over 4 times 2. And how we're going to find the position for quartile 3, n plus 1 over 4 times 3, so it's going to be 3 times that. So that's how you find the positions of the quartiles, not the actual quartile numbers, but the position of the quartile. So why don't we find the position of the quartile? So for quartile 1, I'm going to put the position for quartile 1. Well, it's going to be n plus 1. What's that going to be? 5, because we got a sample of 5 numbers. 5 plus 1 divided by 4. I'm just putting in this formula up here. 1.5. We don't have a position 1.5, we have a position 1 and a position 2. So 1.5 would be halfway between the 1 and the 2. So we're going to have to take the average. We're going to have to take the average. See, we're going to have to take the average in here. Oh, it's not turning on for us. And we're going to have to take the average of these guys in here. Because halfway between 1 and 2 is going to be the average of those two. So what's the average of 5 and 12? That's going to be equals 5 plus 12 divided by 2. It's 8.5. And look, that's the same 8.5 as we got down here for Q1. How do we find the position for Q2? The position for Q2 is going to be 2 times n plus 1 over 4. So it's going to be equal to 2 times 5 plus 1 divided by 4. So the position is going to be position 3, position 1, position 2, position 3. That number is going to be 18. Let's put 18 in here. And so Q2 is 18. And that's exactly what Q2 was here, 18. And then position for Q3 is going to be 3 times n plus 1 over 4. So it's going to be 3 times 5 plus 1 divided by 4. It's going to be position 4.5. Again, there's a position 4 and a position 5, but there's no 4.5, so we're going to have to average out these two numbers. So let's average out the 22 and the 27. 22 plus 27 divided by 2 gives us 24.5. And again, that's the same Q3 we have over here. So basically, Excel would have done the work for us, and it could have done, but if you're wondering how you actually would have got them by more manual calculation, that's how you'd have done them. Now Excel, I'll show you one more thing. Excel does actually do box plots. It calls them box and whiskers. They've got different names. But it doesn't adhere to the same theory that we have to actually plot these points that we came up with for Q1, Q2, Q3, lower limit and upper limit. But I'll show you how you do it anyway, because it's still giving you a good visual of what's going on. So you highlight your data. Well, I have to get rid of this first. You highlight your data, and then you press insert here, and you go over to this one here, statistical, and go down to box and whiskers, and that gives you the chart. That gives you the chart. It's kind of on its side. We kind of need to rotate it down to make it look like ours. And what Excel tries to do, in fact, it doesn't give you a theoretical box plot. Like we've come up with a theoretical one. We don't believe that your upper limit should be greater than 48.5. What they've tried to do is stick only to the numbers we have here, as if this was our population. There's a small exception to that, but basically that's what they're trying to do. So if you look at the upper limit here, it's 27, it's about 27. And if you look at the lower limit here, it's 5. So what Excel tries to do is actually fit that to a box plot rather than take the theoretical position that this is a sample.